What's up, guys? So today, don't really have anything scripted. I just thought I'd put a video together. Just going to draw some reactions and show you how before you ever do the product, how you would go through here and systematically figure out what to worry about. Okay. So let's go ahead and draw some reactions here. Let's say we have this double bond, and let's say we have BH3, THF. Let's say this one is hydrogen peroxide, base, water. And now let's see what's another one we could do. Let's jump to a carbonyl. And let's do this. Acid plus. And I guess for now we'll start with that. All right. So the first thing that you want to do in any reaction is you want to focus on your functional group. And I'm pretty sure most of you are familiar now that the reactions are typically written in a certain way. You're going to have your main functional group on the left-hand side. You're going to have your arrow, and you could potentially have something above or below or just above. And that's the basic format. So the first thing that you want to do is you want to look at your functional group. So in this case, what I'm going to do here, and I've talked about in some of my videos and posts, is that you want to look at your functional group and see if it's a nucleophile or an electrophile. Okay. Now, any line in organic chemistry can be written as a plus and a minus. So in this case, we could remove this double bond and we could imagine writing a plus and a minus like that, or we could do it the other way. Now you might be asking, well, if you can do it both ways, how do you know which way it goes? And we can see here that we've got a negative, but the one I want you to focus in on is the positive, which is a carbocation. Now I'm pretty sure all of you are familiar with the fact that there's a lot of talk about carbocation stability. So you always want the carbocation to be on the most substituted carbon. So that's why I've chose to do it this way. So if you have a double bond, remove the double bond and write your plus on the most substituted carbon, and then the other side will be your negative. Now, how does this help us? Well, we know that negative charge is a nucleophile and a positive is an electrophile. So we can see the double bonds are actually acting both as a negative and a positive, which means that it's both an electrophile or a nucleophile. Typically, double bonds will attack first and act as a nucleophile. So this way we know which side will attack, okay? Now, if we came down here, we could do the same thing with the carbonyl. What's nice about a carbonyl is we have an electronegativity difference. So we can see that the oxygen will be negative and the carbonyl will be plus. So this right off the bat helps us figure out how these things are going to react or behave. Then we want to go ahead and move to our reaction arrow. Now we'll see here that in this case we have a numerical sequence and we have a comma sequence. The typical way to do this in the textbook or professors across the world really is that typically the first thing is what you want to focus in on, whether you have a numerical sequence or just a comma sequence. So that's going to be the thing that we want to pay attention to in the first. The second is we're going to want to pay attention to that, okay? So we do it in that one. Now we look here, we can see this plus and minus. This one's pretty simple to see or easier in the fact that we can see that it's probably going to be this massive thing here. If, for example, we're not doing a mechanism, in this case we don't have the products, we want to figure out what's important. So we know that carbonyls, from what you're taught, is typically you don't worry about the negative charge on the oxygen if we think about it this way as attacking something. Usually we see that as adding a hydrogen, so we think of that as protonation. So we usually think of attack here. So then that means that carbonyls we want to think about as electrophiles, and that means this whole thing is going to be our nucleophile. So we found our electrophile-nucleophile pair. One other thing I want to point out in here is that we'll notice, let's get this one. We'll notice here that we have H+. Sometimes you might see H+, sometimes you might see a specific acid, let's say HCl or H2SO4. Usually, I would say greater than probably 95% of the time, when you have an acid, and definitely when it's just an H+, that is going to be a catalyst, which means that you are going to use that in your reaction. But when it's done, you're going to regenerate that, okay? So that's just the last point that I want to make. So hopefully this video has been helpful to show you that, let's say you get to a reaction, you have no idea how to start, that you'll be able to break it down looking at it in terms of nucleophiles or electrophiles.